Welcome to Spring LIB.
Hi everyone, so what we have here is a ball of mass m that is moving along a circular path that's given by r is equal to 2 times rc cos theta. We know the arm has a constant angular velocity theta dot equal to theta dot naught, and since we know it's constant, we also know that theta double dot is equal to 0. What we're asked to solve for is the angle of theta, which is less than 45 degrees when the ball leaves the surface. The way we're going to do this is use and apply our knowledge of normal, tangential, and rotational motion, and combine that with free body diagrams and develop equations of motion using Newton's second law, namely F equals ma, to solve this problem and solve for this theta. So let's go ahead and get started. We know that r is equal to 2 rc cos theta. Therefore, r dot will then be equal to negative 2 rc sine theta times theta dot. And we know that r double dot would then be equal to negative 2 rc cos theta times theta dot squared minus 2 rc sine theta times theta double dot. Since we know that theta dot is constant and theta double dot is 0, what we can do is we can go ahead and solve for our acceleration in the r direction. We know that ar is equal to r double dot minus r theta dot squared. What this gives us is an ar that's equal to negative 4 rc cos theta times theta dot naught squared. Next, what we're going to do is draw our free body diagram. So here's our mass, and here is the r direction, and here is theta direction. Here is the force from the arm, and right here this is our angle theta, and this is our normal force that's being applied from the surface, and here's our weight force. Now at this moment in time, since the ball will be leaving the surface, this normal force is in fact just equal to 0. So now we can resolve our forces in the r and theta directions and apply Newton's second law to solve for the theta at which the ball will start to leave the surface of the cylinder. So resolving our forces in the r direction gives us the net force in r is equal to m times ar. Then we see that negative mg sine theta is equal to m times ar, which we have solved for previously. That was minus 4 rc cosine theta times theta dot naught squared. What we can do is we can isolate theta in terms of tangent theta and say that we see that tangent theta is equal to 4 rc theta dot naught squared all over g. Isolating theta gives us that theta is equal to the inverse tangent of 4 rc theta dot naught squared all over g, and this is our final answer.